Question 12. An aeroplane flies due north from a town P from a town T on the equator at a speed of 950 kilometers per hour for 4 hours to another town P. It then flies eastwards to town Q on longitude 65 degrees east. If the longitude of T is 15 degrees east, A part of the question represent this information in a diagram. B part, calculate the Roman figure 1 latitude of P correct to the nearest degree. Roman figure 2, distance between P and Q correct to 4SF. Take pi as 22/7 and radius of the earth as 6,400 kilometers. Solution. So I want to illustrate the information in a diagram. You start by drawing the earth as a sphere and you draw the two principal axes, that is north-south and east-west. These are the two principal axes. After that, you draw the two reference points, that is the equator, latitude 0 degrees, and the prime meridian, longitude 0 degrees. So let's draw the equator. And the two reference points passes through the center of the earth. They are great circles. You must know that. If you check the question, the two longitudes are on the east part. For that, let's draw the prime meridian on the west. Okay, so this is longitude 0 degrees. The two longitude, though you have 65 degrees first, if you are moving from 0, you have to encounter 15 first. You have 15 first before you have 65. So let's locate the point. Now T is on the equator. The longitude is 15 degrees. So this is point T, latitude 0 degrees and longitude 15 degrees. Now the aeroplane flies due north from a town T. So from the north we have another small circle here, which is also known as parallel of latitude. So it flies from T to P. So we have P somewhere here. So this is P, and because from T now, see that from T to P due north. Then this is tan Q. This is tan Q. Q is longitude 65 degrees east, but the latitude is unknown. But we only have to find the latitude of P. Okay, so this is the information that you have in the diagram. The reason why point Q is here is because the question states that after turn P, the aeroplane flies eastward to Q. That is from P. You have the east part. That is why Q is somewhere here. B part of the question, latitude of P. That is B, Roman figure 1. Latitude of P correct to the nearest degree. Note that P and T, they are on the same longitude because from T you move to P. So the distance is needed before you can get the latitude. And you have the speed from T to P to be 950 kilometers at 4 hours. Distance is equal to speed is distance over time. If you make distance the subject, it becomes speed times time. That is 950 times 4, and you have 3,800 kilometers as the distance between P and T. Let latitude of P be theta degrees north. That is where point P is located. It is along the equator because the plane move from T on the equator to point P. For that, we use distance along great circle formula, and that distance is this. The distance is 3,800. The angle is unknown. That is the latitude of P over 360 times 2 times pi 22 over 7 times radius of the earth 6,400 kilometers. If you simplify the right hand side, you have this result. You make theta the subject, you multiply 3,800 by 2,520 and divide 8 by 281,600. You have it in this form, and that is 34.01 degrees. To the nearest degree, you have 34 degrees north as the latitude of P. Roman figure 2, distance between P and Q. You can see P and Q. These 2 points are not connected to any of the great circles. So the distance between P and Q is along parallel of latitude, and that is a small circle. Such a distance is obtained by using the same formula, but in place of capital arrow, you have small arrow, radius of parallel of latitude. That radius is equal to radius of the earth times cos alpha. Alpha there is the angle of latitude. Alright? Now, and theta is the angle along longitude. So you have the angular difference. Since the points are on the same side of the equator, that is P, Q, they are on the same side of the equator. The angular difference is through subtraction. So you have 65 degrees minus 15 degrees, and that is 50 degrees, the angular difference. Alpha is 34 degrees latitude of point P, because Q is from P. Alright, so the distance is equal to 50 degrees over 360 degrees times 2 times 22 over 7 times 6,400 times cos 34 degrees. If you simplify, you have this, and you check cos 34 degrees, you have this result. If you simplify further by multiplying, you have this, and when you divide, you have 4631.873. To 4SF, you have 4,632 kilometers as the distance between P and Q.